Good afternoon, everyone, and welcome to the webinar. Right, we're just gonna give everybody a minute to settle in as people are arriving. We can see there's lots of people arriving just now. So welcome, everyone. All right, great. So if you've just joined, welcome so much to our webinar. We're just going to wait a few seconds for people to arrive and to just settle into the webinar, and then we're going to start. Just before we start, my name is Anja. I'm going to be your host today. So I will introduce the speakers to you in a little moment. And if you have any issues or questions throughout the webinar, please feel free to message me directly or to type them into the chat box. Great. Okay, I think everybody has arrived now. So once again, welcome to everyone to this live webinar today. Our topic today is Supply Chain 4.0 and specifically the procuring of metal parts in a digital supply chain process. And today's webinar is brought to you by a collaboration of companies, including Dymanex, NetTrain, and Additive Manufacturing. And before I introduce the companies and the speakers to you, just a few notes about the webinar. So first of all, just to make you aware, we are recording the webinar today, so it will be available after if you would like to watch it again or share it with some of your colleagues. So you will receive a copy of the recording after the event. Also, at the end of the event, we will have a live Q&A session. So if you would like to ask any questions, you can either type them in the chat box or Q&A box during the webinar, or you can simply ask them live after the webinar. And there will be an option to unmute everyone and ask the questions directly to the attendees. Great. And again, for any other issues, I'm here as a moderator and can help at any point. Excellent. So let's have a look at who the speakers are today. So today we are joined by Alexander Boers, and Alexander is the co-founder of the Dutch company Dymanex, who has a novel digital platform making additive manufacturing available for industry. Welcome, Alexander.
Pleasure. Thank you, Anja.
There you go. Then we're joined by Joris van de Zande from NetTrain. And Joris is the strategic buyer and 3D printing program manager at NetTrain, who's of course the Netherlands' national rail service provider. Joris, great to have you today.
Thank you, Anja.
Excellent. And then last but not least, we've got Phil Kilburn from Additive Manufacturing. And Phil is co-founder and sales director at Additive Manufacturing, who specialize in the manufacture of metal parts using a new technology called additive casting. Welcome, Phil, if you give us a wave.
Hi, everybody.
Great, welcome. Excellent. So we'll kick off the presentation with Alexander. So Alexander, I'll hand over to you.
Thank you, Anja, for your introduction. It's great to join this webinar. And as we are focusing on the digital supply chain with additive manufacturing or additive casting, let's share how we do this and how we are working with customers like the Dutch Railways on stock reduction and on improved lead times. When you have a background in supply chain and in the parts domain, you will for sure recognize the image on the left. It shows the struggle of supply chain people to balance the risk of non-availability and prevent any supply or overstock. It's not an easy job, as we all know. Just when you scrapped the non-movers, an order comes in for just that single part which didn't move for the last 5 years. And with our experience, we can say that in many cases, about 70 to 80% of all stock positions in warehouses are slow or even non-movers. What are the main causes of this? Well, first of all, we have long lead times, especially for spares in remote locations. We are dealing with minimum order quantities that result in an overstock, because very often only a limited number of parts of this volume is needed. Maintaining capital goods like trains require service lifetimes of over 30 years. And I believe Joris can explain more. I believe some trains are even older in their service lifetime. And when these parts are phased out, a last time buy will lead to additional stock to cover future demand, which is very difficult to predict. Overall, the predictability of spare parts is a real constraint of companies. So what do? They want to be better on the safe side and add some stock in case of. And the end result is a physical stock claiming working capital for no valid reason. And instead, this money could be better spent on improvements with clear return on growth in existing or new markets. We can do better was our thinking a couple of years ago when we started Dymanex. What if we could create a digital library of parts which you can access around the globe and print these parts where you need them in the exact quantity required? The benefits of such a solution would be reducing the stock holding cost, reduction of lead times to resupply. It's a reduction. I'm back again. Yes, sorry for this. The parts that are manufactured on the demand are absorbing variability, and you are also able to produce only what is needed with no minimum order quantities. If you combine all these elements together with additive manufacturing of additive casting, you have also an opportunity in adapt improvements and make customizations on these parts. And by combining these two elements, you have an ideal situation to be more efficient in your digital supply chain. Some customers of us are now creating digital libraries to offer availability around the globe for these parts, but also for small series, tools and fixtures. And for a well-known OEM, it means today that spares for equipment lines are now available in, for example, Mexico and Brazil within a couple of days, instead of a lead time of 8 to 10 weeks. And for sure, in many cases, the parts in AM may be higher in cost from a direct cost perspective. But if you look for it from a TCO perspective, so you include costs like tax, customs, transport, lead time, and order management, the cost of AM and additive casting are justified. From our point of view, a TCO approach is crucial in deciding whether to move forward with additive manufacturing or additive casting. But then the question is how to find these business cases in a scalable manner, how to benefit from it in a digital supply chain. And therefore, we offer a data-driven platform which supports three main activities. Not only the software is developed by us, but we also guarantee the quality of the parts that are processed through the platform. And we can manage several challenges of companies of today. For example, we solve the problem of analyzing hundreds of thousands of unique parts and assess the printability potential of these unique parts. And we can now do this potential assessment in a matter of hours and perform this assessment on an ongoing basis and present to you the actionable insights through the platform. So we link the analysis directly to the parts that are involved. Most of the technical information, often 2D, is incomplete and contains very often unstructured data. It has to be converted, digitized, and scanned to create a file or information which can be processed by a printer. Therefore, we offer in the platform an automated workflow, not only for you as a customer, but also for our partners, like the scanning, engineering, printing, post-processing services, and the logistics. This is what we call the end-to-end solution. Another topic that we encounter with many customers is the matching process of traditional materials and the materials that are used for additive manufacturing, but also for the post-processing. And that is something that is also included in the platform. Let us zoom in on the technology of additive casting. As we are an agnostic platform, we can offer the solution to serve customer needs independent from technology or material that are available. Recently, we introduced therefore a new technology in the platform, calculating the business case not only in additive manufacturing, but also in additive casting. It's a great technology, and Phil Kilburn from Enable will elaborate more on this later in the webinar. Offering these both technologies, so AM and AC, is of interest of our customers as it increases the potential for cost reduction, like parts with larger dimensions or higher volumes, Both technologies offer a speedy alternative compared to the traditional way of operating. And our dashboard of business targets calculates the impact of reduction in lead time of AM compared to the traditional manufacturing. You will need, for example, less stock in case parts have a lead time of 5 days instead of 90 days. Furthermore, we combined MOQ, stock on hand, the service lifetime, and technical data like dimensions, material, and weight to create a selection of parts that offer the best return on investment for AM. From a selection, you will see those parts contributing to the inventory reduction depending on the service levels and the technology. Based on these outcomes, you can focus your efforts on those parts that create a cost reduction on the short term. This cost reduction can be invested in the next digitization and grow the AM potential and cost reduction on the longer term. So a flying wheel of digitization and cost reduction starts to run. So in the data jungle you are today, you are now able to focus your time and your resources on those parts with the highest chance on return in value, like lead time and stock reduction for additive casting or additive manufacturing. One of the companies managing their activities based on this platform is a customer of us, the Dutch Railways. And before we move to yours, I would like to hand over to Anja to introduce yours in this program. Thank you,
Excellent.
Anja.
Thank you, Alexander. Thank you so much. So great to see what is possible with a digital platform and that can sift through a large amount of information really quickly to really help you find a partner to source all of these parts in a digital supply chain. So it'll be really interesting to see now in Joris's presentation how you have already implemented some of these processes at NetTrain. So Joris, please, over to you.
Thank you, Anja, for your kind introduction. Just say that NetTrain is more the older name of our operation company. It's just NS, doesn't matter. Just the introduction of NS. NS is called as well the Sustainable Mobility in Holland. I'm very proud to work for NS. Oh, we have a nice flying birds here. I'll wait till all the... Yes, so as I already introduced NS, we really have sustainability high on the agenda. I'm very proud of that. In 2017, we already mentioned to run 100% wind energy of our trains. And we have also a goal, and this goal is also connected to the 3D printing program. It's about circular purchasing, to buy the materials as circular as possible. Our goal is in 2030, we want to buy as much as possible circular items, reuse maximum our materials, and have no waste in our offices, trains, and workshops. So linked to that, next slide, Alexander. Yes, we started additive manufacturing in 2017. Was not from a perspective of sustainability, but was more from a perspective of availability. As the people who are working in the rail industry know that what Alexander was already mentioned, our assets, the trains take 30 years or longer in lifetime. And then you have to deal with availability. That means that spare parts have to run some spare parts in the train for that long of period. And we still have to be available for running the train. So we are confronted with a lot of obsolete items. And at that time, I think before 2017, I saw movies on YouTube about 3D printing. I thought, okay, this is the way forward. So we, I went to my management and said, okay, let's start a pilot with 10 items. And we started in 2017. It was already in the beginning of with Diamonex, because I wanted to have just one partner in this. and we printed our first parts. That was at that time plastic parts, but we during that period we have now more than 150 parts printed, which are available in the trains. Unique parts are these. Different materials: metal, plastics, ceramic. And as of the beginning, I was really focusing on cooperation, because this is a huge thing, and we are working as well in our company with different people, with engineering, supply chain, quality assurance, purchasing, of course, but as well outside with, at that time, startups like Demanex, with students, other startups, with knowledge centers, and with, of course, the current real industry OEMs companies. So a lot of people together. So, but that makes it interesting. So we call it sometimes to create an ecosystem, and I think that has also to do with the digital supply chain later on. Okay, and next slide, Alexander, please. Thank you. Now the vision picture. Maybe you can push the button, because there should be a train in. The vision is that we want to create a digital supply chain, which result in a less waste in the supply chain. I will tell you later on. I put the Spotify because I think there's an analogy to Spotify in this. I see two worlds creating. There's a production world separated from the design world. Now we have companies, they do the design, and in their supply chain, they create the products and produce a product for us. But what I see in the future is that there will be more separate companies which are linked differently, not in a line, but more in a triangle way, as I will explain later. That means that you can extend the supply chain as well. And in this picture, like Spotify, we print whatever we want, everywhere we can print the item for the trains, nearby our trains. The drawings are in the cloud-based platform, like Demanex. These are put there by our OEMs, and when we print, we pay like in Spotify. We pay a small fee. That's the vision we have for the future. Next slide, Alexander, to explain more. More in detail where the waste is. At NS, we can look at the waste and enable use 3D printing to reduce this waste. Is that with 3D printing you have hardly any setup time. So we have here, for instance, the red one is an item for the Eurostar to London. We needed that in a few days because it was needed for the safety reasons. Otherwise, the train could not run. And we managed this to produce in 5 days. So the time to market is very quick with 3D printing. The other point is that on one batch you can print different parts at once. So the MOQ running a printer, the MOQ can be 1 instead of 50. That saves also a lot of stock, overstock on our side. And the third thing is you don't need any special tooling. That's linked to Enable, where you don't need any molds anymore. So you don't have to invest in high capital molds. And you can produce only for instance, what we did with sand molds. Next slide. Then the waste in the network. Of course, less transport because you produce more nearby the workshops. And then the extent of the supply chain is possible. So when we have a factory, I think that's what we all saw during the lockdowns, that we could not get the parts anymore because the factory was closed in Italy, for instance. And that was it. We had to wait for our parts. Luckily, we had a lot of stock, so the problem was that not that big. But it was much easier when we could easily extend this to another location in Europe or even in Holland, even better. That's why the extent of the supply chain is an important part of this. And there we want to work with kind of triangle where you have the designer, the OEMer, you have the platform like Demanex with their print hubs and sand casting companies, and then we can order when we want, and then have a kickback to the OEMer. These business models we are testing right now with our suppliers OEMers. And the last time is then when we have it in the cloud, and everybody has the same data available, you have no waste of quality issues, of less quality issues, because you have all the same information. Next, and then at the production location, of course, the production with 3D printing or with sand casting, you have less waste. Like for instance, with milling the parts. And the other thing is the design. You can optimize the design. You can use honeycomb by structures, and you can also make one piece of parts instead of assembly parts. It's also we tested this as well. And the last thing is that we use recycled material for our parts, and I think this is becoming more and more important. As I already told you, we have in 2030 we have a goal to purchase as much as possible circular. So we have to take this step as quick as possible, and that has to do with metal, aluminium, metal, where you can use as much recycled aluminium, or with plastics. Next slide. Okay, here we have a quick view. I think it's maybe a little bit small, but one side, the reasons we're printing. They can be cost reasons, obsolescence reasons, and we also just tested materials with this. And on the right side, you can see that most of the plastic parts we use the PA12 material, and on the metal parts we used the traditional metal because we used the mold technology, the sand casting technology. And Phil will explain later more about this. And here you have some examples. On the left side, we needed 40 parts of these for a train which had to run for a couple of years. We don't want to make a new mold, too expensive, and we printed the sand molds, 40 pieces for this item. Everybody happy. And then the other parts, one is long lead. On the right side is a long lead item. We printed the sand molds and cast it ourselves to reduce the delivery time. As you can see, because this is an interesting technology for us, because it's very if you see these items, they are bigger items, very simple in structure, not too complex. And that's why this technology reducing the stock levels, because not a high MOQ and short lead times in this, because we don't have to wait till the tools are made. Next slide. Okay, and the challenges. Yes, of course we still have a lot of challenges. We want to scale, of course. We have 150 parts and we have a total, I think, 80,000 parts. So we are not there yet. But the data is very important in this step. We are working on the data part. So That's one thing. The other thing is that the change management. More and more people get. Oh, sorry. More and more people get know with 3D printing. It's not a simple tool anymore. They can see the items we printed. And what we also want to do is the change at the real industry. We are an end user. We don't want to become a producer. We don't want to become a design for application of trains. So therefore, the OEMs are still needed, of course. So we really want to work together and change the industry to have a digital supply chain and to become more sustainable. Thank you very much.
Brilliant, Joris, thank you so much. It's really interesting to see how you're starting to scale it, and yeah, interesting all around. Now, we already have plenty of questions coming in, so thank you very much to everyone asking the questions. We'll have one last section that Phil will cover, and after that we will go to the Q&A and answer all of your questions. So Phil, I'll hand over to you to talk a little bit about your additive casting technology.
Thanks, Anya. So I'm Phil Kilburn. I've been involved in additive manufacturing for almost 30 years on both polymers and metals. I'm sales director at Enable. And what we've done, we've combined 3D printing with traditional casting methods. We call it additive casting. We've got 15 years experience between us in supplying castings in the UK. Of a value of about £7 million, and we understand 3D printing and the process and how foundries work, so hopefully that gives you peace of mind going forward. Next one, please. So what is additive casting? So what we do, we'll take the files, either you upload them directly or via the Dymanex platform. And what we do is we validate and check the parts for casting. We also do some casting simulation before we pour metal. We then print the pattern or the mold, depending on which process we're going to use. And then using a foundry that meets your requirements, we'll cast using traditional methods. The parts are then inspected to the ISO that you need and delivered directly to you. We can also do finished machining if that's required. So the main benefits from this is, if you look at the UK, there's 450 foundries in the UK. They tend to focus on different sectors, so aerospace, automotive, rail, and then they focus on different alloys, so aluminium, steel, cast iron, magnesium. And then they've got different quality systems. So when you combine these together, there's about 17 million variables, and without you select the right foundry to meet your criteria for products you need. Next slide, please. So we've got three processes. We've got vacuum additive casting. Now this is for small components, thin walls. The component's about 150 by 200 millimeters. The problem with this is it's limited to aluminium and copper alloys. So quite limited applications. Then we've got investment additive casting. So this is your traditional investment casting using air, vacuum and centrifugal casting. And then sand additive casting. So this is for your cast irons, your large parts. So the largest part that's been cast using this process is 60 tons. So that's equivalent to 9 fully grown elephants. So quite large components. Next slide, please. So where do we fit in the market? So you've got 3D printing, which, if you remember, was going to take over the world in the early noughties. But I think what it's done, it's found its niche now in parts that have got thin cross sections, the complex components, where people have got quick turnarounds and relatively small batch sizes. And there's still relatively high cost per component. And then at the other end, you've got traditional manufacturing or castings, which are used, are viewed for large production runs where you need tooling. And it's normally not viewed as economic for prototype components. And you've got long lead times there, certainly in castings for quotes and for your cast components, where you could be waiting weeks for a quote, a month for components. And we've tried to bridge that gap between where we're using, we can use for prototypes or production components with no tooling costs. And because with no tooling, it means you can cast parts without draft. We're using qualified materials and processes, and we can cast components that can't normally be cast by conventional casting processes. And one thing to remember is with prototypes, you're using the same process for your prototypes as you are for your production runs. So you're not going to go through a secondary qualification process. Next slide, please. So just a quick cost case study. So this is a vacuum additive part. It's about 170 diameter by 70 mil high in cast aluminium. When we looked at this, the casting using additive casting was about £400, and we went out to check pricing against direct metal, and we were looking at quite a large range between £2,000 and £6,000. So it's certainly worthwhile tying up with Dymanex to get optimum prices on these. But one of the things you've got to remember is that we're looking at a 4-week lead time for our parts, as opposed to direct metal, where you're looking at about 2 weeks. Next slide, please. So if you look at the sectors, standard sectors that everybody's really involved with, I think direct metal has focused more on aerospace and automotive, and marine and rail have been not focused so much on. And I think this is down to the size of the components that are required, and also the alloys. If I look at what we've been had most inquiries around, it's large components in ductile irons and legacy parts where the patterns have been lost for the castings. Next slide, please. So what we're offering, so we're looking at reduced lead times for prototype and production castings, reduced costs. Again, I keep saying it, we don't need tooling, so it brings our costs down. And because we've got an agile process and we can tie in with Dymanex, we can help reduce inventory. And this completes, this reduces waste. So we're reducing the inventory, but also we're supplying near net shapes, so we're reducing the machine time required. So hopefully Joris, it addresses some of the issues that you're trying to address.
Phil, I think we can't hear you anymore.
Proven quality systems. Next slide, please. So thank you very much for that. And please contact me if you need anything.
Excellent, Phil. Brilliant. So thank you, first of all, to all of our presenters. Alexander, if we can move to the next slide real quick. And we had quite a few questions from the audience. So thank you very much for everyone who submitted the questions. So let's see what the questions are. So the first question is for Joris. So Joris, when OEMs already have a lot of stock, even if they are slow moving, they may hesitate to scrap some of the parts and move to a new manufacturing or additive manufacturing method. How do you convince OEMs when you face a situation like this to change?
I think in the real, I don't know where the question is coming from, but in real, normally the OEMs don't have that much stock anymore. The stock is more on the side of NS. But I'm as well confronted with this, where we saw, okay, these are interesting items to produce with additive manufacturing, but we still had a lot of overstock. So where we are looking now is more looking at new trains where we are buying, or new systems that we are directly looking at the possibilities of 3D printing or additive casting, because then we are not, otherwise maybe we have to buy strategic stock. We take it on stock for 30 years and then throw it away. So, but yes, there's still a lot of interesting items where we cannot directly, it doesn't have make sense to throw them away and to produce them another way. But we can look at these items and then look at new trains where you have the same items and then develop new, use the new technologies. Yes, I hope this answers the question.
Great. And feel free, anybody in the audience, to also post follow-up questions. Another question, probably for Alexander. So are companies actively considering creating digital warehouses when developing new products?
Yes, good question. And indeed, what we see is that many customers are now more interested in the TCO, so in the total costs that are involved in operating non-moving stock or slow-moving stock. And there's a tipping point in where you decide in the financial perspective to either invest in more stock positions or warehouses and relocate stock, or where you would say this is of no use at all because it's inefficient and the costs do not outweigh the creation of a digital library where you can print the parts on demand. So it's in most cases a pure financial calculation, which is offering the best insight in what choice to be made.
Okay, so speaking about KPIs, the next question is also for Joris. The question is, how are you capturing the savings made, for example, financial or sustainability related savings, when you're using your AM for producing parts? So are you collecting this information somehow?
Yes, that is also done on the DMNX platform, where we collect the technical and also the supply chain data, and there are prices included as well. And we, together with the DMNX, they had the standard formula to calculate. And give me an example: when you have an item, for instance, where we have to wait for 200 days, and you can produce it in 20 days, and there's a high variation on that part, that means that you can lower the stock. And it's a formula behind that. And with this, we can say, okay, with lowering the lead times, we can reduce this kind of stock. Now, stock multiplied by the price is the working capital we're saving. And these savings, Alexander showed as example. So there's a dashboard. That's how we collect these parts. That's how we select the parts. And at the end, we also look, okay, is this true? Is this really calculated? What we calculated before, is this also actual in the actual situation? That's how we do it right now. Yeah. And the sustainable, maybe one remark on the sustainable, because I just started to be a project manager for this as well. So I also asked DMNX, okay, how can we embed this as well? And okay, what you do is, instead of working capital reduction, you reduce the number of material in kilograms on your stock. So that's a saving as well. So that we we did as well to ask, because we have this data available, we can calculate that directly next to the financial impact.
Excellent. Thank you very much. Joris, you're very popular. So another question for you. What appetite has there been in the organization to improve data cleanliness and completeness, for example, standardization, as a result of all these efforts working with AM?
Yes, now we were lucky that not only for additive manufacturing, but in the whole NS organization, we want to be more data driven, make decisions based on data. So that helps me a lot, because then I can connect to this vision. Okay, we want to do that as well with additive manufacturing. And my colleagues were also working on obsolescence management, and we saw that we had to collect the same data. So we see more and more programs running where we need more and more data. I think that's also part of innovation. When you want to innovate and need data. So there's really, the appetite is there to change this in all areas. So that helps a lot. And I think that's also because we are now as a mobility in a situation where our customers, less customers are there. So we have a financial crisis within our company, but that means innovation and a new thinking is needed there, and also data will help with this.
Absolutely. Excellent. We have one question also for Phil. Phil, what is the most common misunderstanding when it comes to AM that you're seeing from prospective clients?
I think the problems are that the materials that we're using for direct metal are people are coming to us and asking for parts that have been machined and then saying, can they have them in metal, additive casting? And so the materials, there's confusion there, and we can give alternatives to those materials. So we're looking at mechanical properties, and it's also useful to know what the end application is as well, so that we can make sure that the if it's got to be chemical resistant, that we're supplying the right materials. And we'll always go back with specifications and let people know what their requirements, so that their requirements are going to be met.
Okay, thank you. We are getting towards the end of the webinar, but I'll try to get another couple of questions in because there are still many from the audience. So we have another question here. How do you convince manufacturers who are already interested in AM internally to change their approach and to embrace an outside solution instead? Oh, that's a really interesting question. So I don't know who should take that, but it's a good question.
Yes, I can try to answer that question, and I think absolutely Joris and Phil can join, because I think it's covering all the three of us. But from our side, AM is not a target in itself. It should serve a goal, and what the best technology is or what the best solution is completely depending on the strategy of the company. And if this is about internalization of production, so of the machinery or the tools that are needed and the software, you need to balance the investments and of course the usage of these type of machines. And as you are using a very high volume of parts in an industry that is well known and with a limited number of materials of applications, then you can of course consider buying new machines or internalize the production. But if you want to cover a broad variety of materials and applications, then it's better to at least mix or collaborate with partners that can do both. Can support you internally, but also have an external capacity to have more the low volume or the rare parts that you need to be available to be produced. And that's something that we see today. It's more on a hybrid model where you can mix internal capacity with external capacity. I don't know if Joris and Phil can add on this one.
Yeah, maybe if I can say something. We were also at the beginning thinking about buying printers. Till now we don't have any printers there, and we see we added for training, and then okay, it's you really need not have to have knowledge about how you can use these printers. What I see is there's also a lot of change still, new printers, new technologies, new materials. So yeah, that's why we didn't choose. But what I saw, as I already mentioned, we don't want to become a producer. But I see some colleagues make the choice for having printers. And I think a hybrid model will be there, because I showed you the picture about printing next to the train. That can be a possibility, but more and more print hubs and companies, smaller companies, local companies are using this. And there's this network we use for printing. So, and I think that's also the separation between that company has to choose between designing and producing. I think that's also what happens.
Yeah, I think you've also got high investment costs, and once you've done that, you're limiting then to a process, because you try and make everything fit that. Whereas if you stay open, you can cherry pick and use the right material, right processes for the application that you've got.
Okay. I don't know if we have questions. We are out of time, but there is one more question. So may I take the last question? Excellent. So the question is around parts for aerospace. So how do you assess parts for quality, for example, qualifications in industries such as aerospace, who have kind of like a highly regulated area?
So I think that's, so from our point of view, from an additive casting, we will use certified foundries to cast the parts for the aerospace industry. And I think that, you may have a different opinion, but I think that that's one of the problems that's held up with direct metal printing of metals, is that the qualification, people have designed and developed processes. Once it's been finished, they've gone to engineer, and engineer has said, well, we need now to qualify and certify the process. And I think certainly safety critical parts are a long way off, but there's certainly polymers are now a standard part in an aircraft.
Yeah, maybe from a real perspective, this is more or less the same, because we have also high regulations as well there. And I think, especially for metal parts, when you want to print them, you have to do a lot of testing afterwards, because you change the original specification. And that's why when you can keep the material, keep casting as you cast it before, then yeah, that you don't have to invest. And there the business cases are interesting. That's why we have a lot of sand casting parts, big parts, sand casted. Yeah.
Yeah.
Yes, I agree. I think the lead time to develop and to qualify, to verify this type of parts is in many cases a bottleneck to make progress, in speedy progress on this. So I agree with both of you, absolutely.
Excellent. So these were all the questions right now, and we are a little bit over the time, so I don't want to keep you for too much longer. So thank you, first of all, for everyone who came to today's webinar. We hope that it was interesting, informative, and yeah, something that was good for you to experience today. Thank you very much to the speakers, Alexander, Joris, and Phil. It's been really great having you on today and hearing about your businesses and your collaboration in the supply chain 4.0 area.
Great, it was a pleasure.
Excellent.
Thank you.
Thank you all. We will send a follow-up newsletter with the recording. Thank you all for coming. Have a great day, and hopefully we'll see you all again soon. Bye.
Bye-bye.
Bye.
Well, thank you, Phil. It was great. I think we catch up afterwards.
You're still recording, Alexander?
Yeah,